Hello and welcome to this Android video presentation on OpenGLES. We really don't have time in this video course to discuss OpenGLES in a full way. That would require a course in and of itself, I believe. The API is extremely detailed, and there are many things that we can do with it. So in today's example, I'm going to use one color to draw a triangle and then rotate it, animate a rotation transformation of that triangle about a couple of axes. So we'll begin by looking at the main activity class. We draw in OpenGL on a renderer, an object subclass that implements the interface renderer. So that's what we're actually doing our drawing on. So we can see that in the main activity, we're getting something called a GL surface view. GL surface view is a class that actually wraps up a lot of this GLES and EGL code and makes it much simpler to initialize a graphics view with OpenGLES. So we get a GL surface view, which will be our destination view. It's going to be the content view of our main activity here. However, we set the renderer on this GL surface view by calling setRenderer on it once we have it, and then that is a new OpenGL renderer. Now, OpenGL renderer I have defined as a class that as a object class that implements renderer. So now let's look at this. First of all, let's ignore this line that says triangle, triangle equal new triangle. I have another class here called triangle. But this renderer class, many of the items in this renderer will be able to be used in any OpenGL application, regardless of what it actually does. For example, onDrawFrame typically clears the frame and then draws whatever shapes, primitives it's supposed to draw. And in this case, it's just telling the triangle class to draw itself. OnSurfaceChanged, we'll get back to that in a minute, but OnSurfaceCreated is called when that surface is created, and this is the first time things are actually seen. The clear color is set, and here I'm setting it to kind of a medium yellow, a medium light yellow color, kind of a 255, 75%, and full alpha. And then I'm setting the depth buffer, just clearing the depth buffer, and then enabling a depth test and setting that the depth function for that depth test is less than or equal. Now what that means is that when the scene renders, it will put farther objects away and then draw nearer objects above them, unless they're equal. So if they're equal, it will draw them at the same level. And for this case, for simple rendering illustrations, this will work just fine. And then there's a Prospective Calculation. This is just putting a hint to OpenGL, which is a very strong hint, by the way, that for perspective correction, it should use the nicest instead of the fastest or some other algorithm for that. So again, I say that much of this code, most of this code can be used in any situation, and copy and paste is just fine with this. The only exception here is the clear color. Many times we clear it to black or to white because we're going to be covering all that up anyway. But in this case, I'm just setting it to a yellow background because I'm going to draw a red triangle, and there's a nice contrast there. We come back up to surface changed. If the surface changes, then this method will be called. The viewport is set to 0, 0, and width and height. This sets up the viewport rectangle, which is top left and then bottom right. And then we're going to use a projection matrix and load the identity of that projection matrix so that we can set up a perspective view. And this says we use the context, which is GL10. And then we're going to have a 45-degree angle of perspective view, which is the aspect ratio, which is the width over the height. And then our depth is going to be from -3 to +100. Now our depth will decrease as it approaches our eye and increase as it goes away from us. 100 is kind of an extreme depth of field. You usually would use something like -3 and +6, or maybe, but this is where our eye is in relation to the 0, 0, 0 point of our x, y, and z axes. And then we switch the matrix mode to model view, and then we reload that matrix. And that's all we're doing here. So again, this is kind of boilerplate code, and you can use this again and again and again in your GLES coding. On draw, typically we're going to clear using the buffer bit with the color bit, and then we're just going to draw our object or objects. So now we have a single primitive object here called triangle, and I want to show you that because this is what we're actually going to be rendering. We can see that first I've set up a vertex array, a vertices array, and right now I have some things commented out. I'm going to show you some different things here in just a moment. But right now I have 3 vertices, 0, 1/3, 0, 0.5, -1/3, 0, and -0.5, -1/3, 0. And these are the x, y, z coordinates for each point of our triangle. Now don't worry, we're going to see a little bit later that as we rotate this, z will be going in and out as well. So, okay. Now, let me get rid of this because I really am not going to talk about winding in this at all. I set up another array called vertex order, and here I draw the first point, the third point, and then the second point. I could have drawn the first, the second, and the third. In the original, I decided not to talk about backface culling with counterclockwise winding and all of that stuff, but this is a legacy of that, and you can certainly look that up in the online resources for the Kronos group for OpenGLES. Be that as it may, this is the order that these 3 vertices are going to be drawn. Then I set up a float buffer and a short buffer. A float buffer is just a buffer full of floating point variables, and a short are values, and a short buffer is just a buffer full of shorts. I have them called vertex buffer and order buffer. Here is triangle's constructor. I set up a byte buffer, and I'm calling it here vertex byte buff, which is a byte buffer allocated directly by taking the length of the vertex array and then multiplying it by 4. 4 is the size of a float. I could have said size of float. That would have been fine. 4 is a little terser, but it really doesn't matter. What this does is it makes a linear byte buffer of, in this case, 9 times 4 bytes, because each float is 4 bytes long. Then we set the order to the native order for this machine. This handles things like big Indian and little Indian ordering for us. We don't have to worry about it. Then I set that as a float buffer, and this actually demarks each value as a floating point value, a 4-byte value. And then I put the vertices array into this vertex buffer, and I set this vertex buffer's position to 0. In other words, we're pointing at the very first element, the beginning of the first element in the vertex buffer at this point. Next, I set up a short buffer, the order buffer. I do the same kind of thing, except this time I'm multiplying by 2 because the short is 2 bytes in length. Again, I could have said size of short, but by 2 is fine. And then I do this essentially the same thing as I did with the float buffer. Here's the draw method. Now, the first thing I do is I enable what is called a vertex array in OpenGL. And this is enabling client state for a vertex array. Anything I enable, I must disable at the end of the draw function. So now I get the vertices into the GL vertex pointer, and I'm saying take 3 vertices at a time, x, y, and z. take them as floats, take them without skipping any values. This third parameter is known as the stride, and I can interleave vertices and color values if I want to do that, but here I'm not doing that. I'm just taking the vertexes and then take them from the vertex buffer. So that sets up my vertex pointer for my model view matrix. And then I draw this with a red color. I'm going to draw in red, 1, 0, 0, 1, this last one being the alpha. Then I'm going to draw using a triangle strip. Why a triangle strip instead of GL triangles? Well, because later I'm going to add some points. I've got them commented out now, but later I'm going to add these points. So draw them as a strip with the length of vertex order, with all of the values as unsigned shorts in the vertex order array, and then use the order buffer to establish the order in which I'm going to draw my elements. Then I disable the vertex array, and then I apply a rotation transformation, and I'm saying before this code gets executed again, take the model view matrix and apply a 2-degree rotation transformation about both the y and z axis. So the x-axis, leave it alone, but rotate this thing simultaneously about the y and the z axis. And now I'm all set. I'm ready to go, and I can run this, and let's see what happens. So I should see a triangle. Actually, it's being drawn 0, 2, and 1. And it's closed because, there we go. And now I'm seeing the rotation not only about the z-axis, but about the y-axis as well. Now, had I enabled backface culling for half of this rotation, as it rotates about the y-axis, I wouldn't be able to see the triangle. So there we go. Now, let's do one more thing. If I disable this, and we'll see what we can do with some additional points here. And if I put a comma here, take this out, and also this comment. And now we have 5 points, and we draw them. Let's say we have 0, 2, 1. We can go back to 2 and then 3, and then we can go back to out to 4 and then 1. Now, because I'm drawing with a triangle strip primitive, it'll draw a strip of triangles in a red color. It won't rotate them because we commented that out. But now, in just a moment, we'll see the result. And there we go. So what we've got is 0, 2, 1, 2, 3, 4, 1. So there we go. So you can see that really the hard part of OpenGL is setting it up and getting ready to draw. The much easier part is actually setting up the rendering. So Triangle is a much easier class to comprehend than OpenGL Renderer. But again, this is good news, because OpenGL Renderer we can reuse in pretty much any application that uses OpenGL. All we're going to be doing is changing maybe the perspective view, maybe the depth of field, probably the depth of field, maybe the clear color that we're clearing the background to. These are the things that we're going to change. But again, we can reuse this code over and over again. So I would encourage you to experiment with this. Use different shapes. I believe in the that you should attempt to draw a square by using 2 triangles and setting that up as either a triangle strip or a triangle fan. Try different things, because this is a truly exciting field and a good way to draw 3-dimensional graphics in your application. Thank you very much.